In today's video, we're going to be learning about graphing lines. Here are our learning goals. So our learning goals for today are, by the end of this video, you should be able to 1. Graph a line in the form of y equals mx plus b. 2. Rewrite linear equations in the form of y equals mx plus b for graphing purposes. And 3. Graph linear systems in the form of y equals mx plus b to find the point of intersection. Now there's some key terms in these learning goals that you need to copy down. So those would be linear systems, or linear system, which is 2 or more linear equations that are considered at the same time, and point of intersection, which is where the points intersect. Before we can graph a line in the form of y equals mx plus b, we need to understand what these certain values that these variables hold. So if we have y equals mx plus b, what does that mean? Well, m is our slope. And you probably learned in your previous math classes, slope is y2 minus y1 over x2 minus x1. So what m is going to tell us is the steepness of our line. It's going to give us our rise over run. Now, depending on whether or not m is a positive or negative number is going to affect the way that we draw our line. So if we have a positive value for m, we're going to be moving up. But if we have a negative value for m, we're going to be moving downward. And then we're always going to run to the right to start. Okay, and b is our y-intercept. Now that we have this information, let's try and graph a couple different lines. So let's say our first line is y equals 2x plus 2. Well, I can see here that my m value is 2, but what it actually means is 2 over 1, right? Every whole number is over 1, so that's our rise over run. And then our b value is positive 2. We always start with the b value. So positive 2, I'm going to go on my y-axis and find positive 2 right here. And that is where the first dot of my line is going to be. And now what I'm going to do is use my m value to create the rest of the dots on the line. So I'm going to rise, because it's positive, upwards 2. So 1, 2, and then I'm going to run 1 to the right. We can do that again. 1, 2, and 1 to the right. You can draw as many dots as you need to create a straight line. Some people need to do more than others. Personally, what I like to do is reverse my rise and run so that I can continue to draw my line downwards. So instead of going up 2, I'm going to go down 2, and instead of going to the right one, I'll go to the left one. So down 2, left 1, and here I feel I have enough dots to draw my line, so I'm going to. There we go. Let's try doing another line, but this time our m value and our y value, let's make them negative. Okay, so we always remember that our whole number is over 1. That's going to tell us our rise over run. And we're going to start with the b value, which is our y-intercept. Here is negative 2. So on my axis, I'm going to go to negative 2. And now my rise over run is going to be a little bit different. Instead of going up, because the number is negative, I'm going to go down. 1, 2, and to the right, I'm going to do 1, and then down 2, to the right 1. And then we can just reverse it. Instead of going down 2, I'm going to go up 2, and I'm going to go to the left 1. Up 2, to the left 1. And let's connect our points to make a line. So, if you've been able to do this, you've completed our first learning goal, which is graphing lines in the form of y equals mx plus b. Let's move to our second goal, learning goal here, which is rewriting linear equations in the form of y equals mx plus b for graphing purposes. Let's change this back to black. Okay, so let's say you have two different lines. Let's see if I can pull up a question here. Let me move that in a better spot for us to see. Okay. So it says the equation for two lines are x minus y equals -1 and 2x minus y equals 2. What are the coordinates at the point of intersection? So let's write down the two equations for the lines that we have. We have x minus y equals -1, and we have 2x minus y equals 2. Are either of these in the y equals mx plus b form? No. So let's rewrite these equations so that we can get them into y equals mx plus b form. Now, you should be able to remember how to rearrange equations. If you don't, we've got another video for that for you to review. So let's just jump right in over here. You could do this a number of different ways, which is a great thing about math. So the way that I'm going to do it is -y equals -x minus 1. And then in order to get my y to be a positive value, you can either multiply or divide both sides by -1. So I'm going to just multiply in my head. So that means I'm going to get y equals x plus 1. Okay? And if we want to rewrite our second one, we can rearrange it as -y equals -2x plus 2. And I'm going to do the same thing, multiply both sides by -1 to get a positive y, which is also going to give me a positive 2x and a -2. So all we're doing is spending time to rearrange and rewrite our linear equations in this form so that we're able to graph them. I'm sure you can already start to pick out what the b-intercepts, the b value is for the y-intercept in each of these lines, as well as your slope, your rise over run. So now we can move to our third learning goal, which is now graphing these linear systems, which are in the form of y equals mx plus b, to find the point of intersection. In the first example, we did graph linear systems, and we found a point of intersection, but we didn't label it. So we're going to go through that process here. Let's get some colors. Let's use yellow. We'll use yellow for this line. Ooh, I'll just draw some lines underneath instead. And we'll use green for this line. Okay, so recall the steps we were using before. We start with the b value. So my b value over here is 1. So my y-intercept is 1. So that's where I'm going to go. And now let's look at my slope. Oh, this is interesting here. It's just x. But if we ever see a variable on its own, we know what's in front of it is a 1. So my rise over run is 1 over 1. So I'm going to go back to my starting point, and I'm going to rise 1, run 1. Rise and run. And I'm going to do the same thing, but flip it. Instead of going up 1 into the right one, I'm going to go down 1 into the left one. Down, left. And that's probably more than enough dots to make a nice straight line. There is my first linear equation. That's graphed. And let's do the second one now. So I've got my y-intercept here. It's 0, -2, so that's where I'm going to start. And then my slope is 2/1. Maybe I should have written that over here for you guys too. Okay, so I'm going to do my slope now, which is up 2 and over 1, up 2 and over 1, up 2 and over 1. Oh, I see, I should have added one more yellow dot on my line. Let's just do it like this to show our point of intersection. Okay. And I'm going to do one more, up 2 and over 1. I also like to do 1 or 2 going down as well, just to create a full image of the line and what it's doing. Great. There we are. So we have our point of intersection right here. Let's get that to be a bit of a better circle for you guys. Okay. So where is that on our graph? It is 1, 2, 3. 1, 2, 3, 4. Okay? Since it's a word problem, we would end it with a statement. Therefore, the coordinates at the point of intersection we're just going to wrap up our video by doing a check. There's always a way to check if your answer is correct, and the way that we do that is substitute our new x and y value that we just find into the original equations to see if left side equals right side. So when we're checking, maybe I'll do this in a different color. Let's do it in pink. Okay, so here's our check. And we want left side to equal right side. So if we substitute our x and y values in, let's see what happens. So the original equation we had here was x minus y equals -1. Okay, so what do I have for my x value is 3, and my y value is 4, equals -1. So 3 minus 4 is -1, equals -1. Left side equals right side. Let's substitute it into our second equation, which was 2x minus y equals 2. My x value is 3, and my y value is 4. 2 times 3 is 6, minus 4 equals 2, and 6 minus 4 is 2, so left side equals right side. Now we're going to attempt to apply these skills to a word problem. So let's get rid of this, take away this, we'll take away our learning goal. Let's put in our question here. Okay. Oops. Let me see if I can just move that up here. Lovely. Okay. So this says, Ian owns a small airplane. He pays $50 an hour for flying time and $300 a month for hangar fees at the local airport. If Ian rented the same type of airplane at the local flying club, it would cost him $100 an hour. How many hours will Ian have to fly each month so that the cost of renting will be the same cost of flying his own plane? Basically, where is the point of intersection? On these two lines, where the cost will be the same no matter which option Ian chooses. So the best way to do this is anytime you have a word problem like this is to create some let statements. So let's do our let statements. I like to start in the question. The question is asking about how many hours relative to the cost. So this is giving me an idea of what my let statements are going to be about and what my different variables are going to represent. So I'm going to use C for cost. I'm going to say let C represent the total costs. Okay, you could say in dollars. It's good to know the unit. Okay, and we also have to know how many hours, so let's use T for time. So let T represent the time flown in hours. Okay. Now, if we go back into the question, we can use certain keywords to help create an equation for each. So let's look at, the first sentence doesn't tell us anything. It just tells us he owns a small airplane. Good for you, Ian. But what we do know in the second sentence is that it can be translated into an equation. What does he do? He pays $50 an hour, okay, and $300 a month for his hangar fees. So that means in option A, Ian's cost, so his C equals $50 an hour. We have a variable to represent that, which is T. Cost him $50 an hour and $300 a month for option number 1. For option number 2, if Ian just rented the airplane, it's just going to cost him $100 an hour. So if he goes with option 2, it's just going to cost him $100 per hour. Now what we're going to do is, because both of these are already written in y equals mx plus b, I like to write this just so I have it as a reminder. I can look at those two equations and see they're written that way. Then we're ready to start to graph. So I'm going to just say that my y-axis is going to just, I'm writing it up here for you guys, is going to be increasing incrementally by 100 for each line. And then for my x, I think I'm just going to do 1. It's just a little tiny for me to write it on here. Okay, so let's start with over here, 300, okay, 100, 200, 300. And then what is my rise over run? $50 over 1. Okay, so I have to go up 50, which is going to be about halfway between these two lines, and then I'm going to go over 1. Okay, up 50 over 1. Up 50 over 1. Okay, hopefully your graph is a smidge more accurate than mine. And then up 50 over 1. And if I want to continue it, you guys remember, I'm just going to do the opposite. Okay. There is our line for the first linear equation. So let's start with the next linear equation. It's okay. Do you notice something interesting here? Our y value is 0. So we're going to start at 0. And our slope is 100 over 1. So I'm going to go up 100 and over 1. Up 100 and over 1. Up 100 and over 1. Okay, I think I see where our points are intersecting here. So, if we look right over here, okay, our points are intersecting at my x value is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, it's in between 5 and 6. It should be 6. My lines are a little off. My apologies. And let's see the hours here. 1, 2, 3, 4, 5, 6. 6 comma 600. Okay, so what this graph is telling me is 6 hours of flying will cost Ian the same which is it's going to cost him $600. But how do I know that my graph is accurate considering my drawing is a little bit out of whack? Oh, I just moved this over. Let me just move it back. Sorry. Okay. Well, what we can do is exactly what we did last time, which is substitute the value into the original equation for our check. So the number we're looking for is 600. Does it actually equal 600? Well, let's see. If he has it for 6 hours, okay, yeah, that gives us 600 for option 1. And let's check the second option. Oops. So that's how we do our check, and we know that our graph did in fact turn out correct despite my poorly drawn lines. My apologies. So hopefully now you feel better prepared to tackle graphing lines, finding points of intersection, but also creating algebraic expressions based on word problems to graph lines. That's my hope for you in this video. Please let me know if you have any questions, and that's it.